Hi everyone, and welcome back to Casper's dApp Developer Series. In today's video, you'll learn how to implement the new Casper Wallet and use what you learned to interact with smart contracts from the browser. For this video, we'll be using the smart contract that we developed in the last video, so if you haven't seen video number 7, go watch that first. We're going to be building our project with React, so get started by opening a terminal window. Navigate to the directory you'd like your project stored and run npx create react app and then the name of your application. I'll name mine video 8. Now cd into your new projects folder and install the Casper.js SDK, Express, and the cores module with npm. Since we'll be using the session code that we wrote for the smart contract in the last video, open up that project in a file explorer and locate the withdraw and deposit wasm. Copy these files and paste them in a new folder within your project's directory named wasm. Now open your project in an editor of your choice. I'll use VS Code. Open app.js in src and delete everything in the return statement. Ignore the error and leave it blank for now. Go ahead and import the Casper client and contracts objects from the Casper.js SDK and import React. Begin the app component by defining a new React state variable public key and setting it to null. Now we need to connect to the Casper Wallet. Soon in the future, there will be a Casper Wallet SDK npm package, but for now it is injected into the user's browser window by the Casper Wallet. You can access this provider with window.casperwalletprovider. We can check to see if the user has the Casper Wallet installed by checking if Casper Wallet provider is equal to null. If it's not null, instantiate a provider instance with Casper Wallet provider. Then create a new Casper client and Casper contract client object to interact with the Casper network. Create a variable to store the contract hash of the smart contract from the last video. That's it for app.js for now. Let's create a component to handle the Casper Wallet integration. Create a new file wallet.js and create a new functional component wallet. Notice that wallet accepts props, with which we will make available the React state variable public key and its setter setPublicKey, as well as the Casper Wallet provider. For this example, if props.publicKey is equal to null, then we assume the Casper Wallet is disconnected and we show the user a button that allows them to request a connection. If on the other hand a public key is set, then we show the user a disconnect button. Now we need to write the request connection and disconnect functions. We'll start with request connection, which just calls on the Casper Wallet to request a connection. If it connects properly, then we forward execution to getActivePublicKey, which we'll write in a moment. Disconnect looks similar, but when it succeeds, it sets the public key to null. Finally, we need to write the getActivePublicKey function, which calls the getActivePublicKey method on the Casper Wallet provider, and if it gets it successfully, it sets the public key within the React state. Any errors that occur can be caught using catch. According to the Casper Wallet's error standard, if error equals 1, the wallet is locked. If error equals 2, then the user did not approve the connection. The Casper Wallet should now be functional within our dApp. Export the component using export default wallet. Create a new file interact.js. This component will handle all of the interaction with the bank smart contract, including deposits and withdrawals. Start off the file by importing these classes and functions from the Casper.js SDK. Define your interact component. We only want this component to be shown to the user if there's a public key in the state, so wrap the return statement in if props.publicKey. For this example, there will be two buttons, deposit and withdraw, and one text input for the amount. Structure your JSX like so. Now create the deposit and withdraw functions. They're both the same, and just call interact with the isDeposit boolean flag. Before we write this interact function, we need a way to load in our wasm session code, so open a new asynchronous function getWasm. In this function we will call our backend server to load in the wasm, which we will set up once we're finished with the front end. We can use the fetch JavaScript API to make a GET request to our backend at the getWasm endpoint, and we can set the isDeposit boolean flag to tell our backend which session code binary we want. With fetch, You can check to make sure a request didn't fail with result.ok. Use this to handle errors that may occur. The response will come back as an array buffer, so acquire it as so, and cast it to a uint8 array and return it to the caller. Now we can write the interact function. Make sure this function is asynchronous so we can use the await keyword. The first thing that needs done is to query the WASM session code. Call getWASM like so. Now we need to build a runtime arguments object. Both the deposit and withdraw session code expects two arguments, contract hash and amount. We defined our contract hash in app.js, and it is available as a prop as you'll see when we implement the interact component into app.js. The contract hash we defined is a hexadecimal string though, and we need to convert it to a CL value so the Casper.js SDK can make sense of it. Let's start by creating a variable contract hash u8 array, and for the value, wrap props.contractHash in the decodebase16 function from the conversions module in the Casper.js SDK. Now convert this uint8 array into a CL value with new CL byte array. The other argument, amount, will come from the text input that's shown to the user. Get this value with document.querySelector and convert it to motes using the Casper.js SDK function CSPR to motes. Package the runtime arguments into a runtime args object. You'll also notice that I've converted these values to a CLU512 and CLKey respectively, as these are the object types that the session code expects. Given that we have all of our session logic prepared, it can now be crafted into a deploy object. Call the install method on the contract client prop and provide the WASM binary, runtime arguments, gas payment, public key, and network. This deploy remains unsigned, so prepare it for the Casper Wallet by converting it to a JSON representation. Open up a try-catch block and call sign on the Casper Wallet provider with the JSON deploy and public key as arguments. The result variable will contain information about the signature request. For example, we can check to see if the user canceled the request by checking result.cancelled. Sign the deploy by applying the user's signature using deployutil.setSignature. Convert this new signed deploy object to a JSON representation. Now send this deploy to the backend with a post request using fetch. Again, if an error occurs, we can catch it with response.ok. Response.text will either give us our error message or our HTTP response, and since there's no error message if we make it past this point, we should be able to log our response. This will log out the deploy hash in the browser's console, and this should finish our interact component. Let's just export it with export default interact. All of the components are now complete. All that's left to do on the front end is to import our components into app.js. Open app.js and import wallet and interact at the top. Now in the return statement, put the wallet component, passing in public key, set public key, and provider as props. Then do the same with interact, except this time ignoring set public key and adding contract hash, Casper client, and contract client. We're now finished with the front end. All that's left is to write a small Express app to handle backend requests. In your project's root directory, create a new file server.js. Start by importing Express, Cores, FS, and Casper Client and Deploy util from the Casper.js SDK. Create a new Express app, and make it support JSON request bodies and Cores headers. Instantiate a Casper Client object for submitting deploys. Open the endpoint getWASM, which will serve the WASM binaries to the front end. Create a variable path, which is deposit when isDeposit is true, and withdraw when isDeposit is false. Now read in the appropriate WASM file given the path above. Note that this is referencing the WASM that we created a folder for earlier. And lastly, send this to the front end as a buffer. Now open the deploy endpoint, which will accept deploys from the front end and forward them to a Casper node. Note that the callback function is asynchronous in this case, unlike getWASM, as we intend to use the await keyword. Open a try-catch block with some basic error handling. Reconstruct the deploy using deploy from JSON on the request body. Finally, send the deploy to the network and return the deploy hash to the front end. All that's left to do is bind our app to a port. I'll choose 3001 because our React app is on port 3000. Note that if you change this from 3001, you'll have to go into interact.js and change it as well. Our app is done, so let's test it. Open up 2 terminal windows in your project's directory. In one, run nodeserver.js, and in the other, run npm run start. A browser window should open for you automatically. Be sure you have the Casper Wallet installed before you test. There's a link to the extension in the description. Your app will not look like this. I've added custom CSS for simplicity's sake. Your app will instead look like this, but will function the exact same. Click Connect to Wallet, put in your password, and select the account you'd like to use. Now before we make a deposit, let's check the balance of our account, which should be 0. Now let's deposit 20 CSPR. Sign the transaction. Now copy the deploy hash and paste it in cspr.live, and you'll see it succeeded and we sent 20 CSPR to the contract. Now we can go back and check our balance and see that it is 20 billion motes or 20 CSPR. Head back to your app, specify an amount lower than 20, and click withdraw. Sign it. Copy the deploy hash and paste it in cspr.live, and you can see that our withdrawal succeeded. We can once again check our balance, and we'll see that we have 5 billion motes or 5 CSPR remaining. That's all for this video. If you enjoyed it, leave a like and be sure to subscribe if you'd like to see more. Thanks, and I'll see you in the next video.